So hi everyone, I'm back again with another video. In this video we are going to do merge sort. Well, it is going to be a two-part video. This is the part A, the first video on the topic. In this video we are only going to look at the algorithm of merge sort. Now before going on into the video, if you haven't seen my video on recursion or if you don't know the concept of recursion, I would strongly recommend you to go and first get the whole idea of recursion. I will link to my video in the description box below. I will highly recommend you to go and check it out. Secondly, if you don't know the algorithm of how to merge two sorted arrays, I will link to another video of mine in the description box below, and make sure you get the whole idea of both of those algorithms before going on further into the video. Now enough of talking, let's just directly dive into the video. Now, merge sort is another sorting algorithm that just sort the array in ascending or in descending order. Before going on into the algorithm, some bullet points about this algorithm. Firstly, that the time complexity of this algorithm is O n log n, and how do we reach this conclusion is a topic of another video that I will make sure I will put on my YouTube channel as soon as possible. But now for this video, just memorize that this algorithm is quite time efficient algorithm, and that's why we prefer it to use as compared to selection and insertion sort. So this is a time efficient algorithm. Secondly, that this is a space inefficient algorithm. And why is it so? Because at every point we have to create another array in the memory that has the sorted values, and we will copy those sorted values in this array. So at every point as we are creating another array in the memory, so it is quite space inefficient algorithm. Now third point is that it is a recursive algorithm. As you can see here already, that merge sort is being called again in itself, so it is a recursive algorithm. Now fourth point, it is quite important that this algorithm belongs to the divide and conquer algorithm family, which means nothing but when we pass this array to this algorithm, it will divide this array in two parts, and then further will divide those divided array into again two parts, and then will divide the array in again two parts, and similarly here we'll divide the array in two parts and then two parts. So it belongs to the divide and conquer algorithm family. And how we are doing this we'll see in the further part of the video. And the fifth point is that it belongs to the stable sort algorithm family. And what does that mean? Why is it a stable sort? Because, for example, take that this one is, as you can see, that this one is present before this one. So after sorting by merge sort, this one will always be present before this one. So it keeps track of the position of the element, so it is a stable sorting algorithm. Now I know to grasp this at first sight is quite a difficult task, but if you will hang with me for more 5 minutes, I will make sure that you will get the whole idea of merge sort. Now before going on to me to explain this, it is important for you to think it recursively. Now let me first get my trying tools. Okay, let me first get my trying tools, and I will make the cursor smaller. There's a mistake that this is not P, this is R. This is I make so bad. I'm so bad at trying, but I'll try my best to not. This is R. Okay, the argument that is passed is not P, that is R. So just forget everything. Just see at this function. This function is getting the value, they're getting an array A. So we are passing this array A. This is the array A. So this function, as I told you, forget everything and look at this function. This function is getting the value P, R, and an array A. The value with the array which is provided is this. The value which are provided is P, which is pointing to the 0th position of the array, and the value R, which is pointing to the 7th position of the array. So this array get added into the stack. So as you can see, this array get added in the stack. The values are A, 0, and 7. Now as you know from the video of my recursion, that to complete this function, first we have to complete all of this function. But for now, imagine that only this function is being added into the stack and the further stack is empty. Only this, imagine it is very important for you to imagine that only this function is being added in the stack, and the remaining stack is empty for now. I'm sorry. Now, as you can see that when the compiler reaches here, it shows, oh, there's an array A which is being passed, which is this, a value P which is 0, and the value R which is 7 is passed here. It goes down and check whether P is less than R. That is true because 7 is less than R. It goes down here. It will calculate Q, whose value is equals to the arithmetic mean of P and R, which means 0 plus 7 divided by 2, which is equals to 3.5, and if we take it in int, that is equals to 3. So the value of Q is 3. Now it goes down, it sees, oh, a merge sort is being called again. So it goes back here, and the values which are being passed is the array A, the value P which is 0, and the value Q which is 3. So the value at here is 3. So the array which is being passed is this, and this gets added to the stack. Now, as I told you, imagine that there is nothing. There is just only two function which is being added in the stack yet. To complete this function has to be completed. If you know my video from recursion, it is the rule of the stack that first this function will get completed and then this function will get completed. Now we were here, and the values that are provided is the array A, the value 0, and the value 3. Now we goes down and we see that 0 is less than 3. We goes back again. Q is being calculated. 0 plus 3 divided by 2 is 1.5. If we take it in int is 1. It goes back here. It calls merge sort again. The values which are provided is the array A, the value 0, and the value 1, as Q at the head at here is 1. So the array which is provided here is this, and it gets added into the stack. Now, as I told you earlier, that forget all of these functions. Just imagine that only this 3 function is yet being added in the stack. Now to complete this function, we have to first complete this function, and to complete this function we have to complete both of these functions. And as we are here, the values which are provided is the array A, the value 0, and the value 1. It goes down here. 0 is less than 1. Q is being calculated. 1 plus 0 is 0.5. So the value of Q at int is 0. As you can see, the value of int is Q is 0, the value of P is 0, and the value of R is 1. It goes down here and it passes the array A, the value 0. It goes down here and then sees that 0 is not less than 0. So this function, when we call this function and passes the value 0 and 0 back to this function, will return nothing. And as this will return nothing, that first it get added into the stack, it will return nothing and get removed from the stack. And as this gets removed from the stack, it is the first time that this function is being completed. As this function is being completed for the first time recursively, it will goes back down here, and then the values which are being passed is Q plus 1. Q plus 1 means Q at that point is 0. Q plus 1 means 1, and R. Q plus 1 and R. Q plus 1 is 1 and R is 1. It goes back here and provides 1 and 1. It goes down and see that 1 is not less than 1. So this function is also being completed. First it was added in the stack, and then it is completed, and this function will also return nothing. So a function will return nothing only that if the array has a single value. So you see the pattern here that the function will return nothing only when the value is only when in the array the value present is single. So this function will return nothing because the value that is present in the array is 4, only 4. This function will return nothing because the value present in the array is only 2. So as this function will return nothing, it goes back here. As both of this function will return nothing, the control flow reaches back to this function, and this function has the array A, the value 0 and the 1, It gives this array this array to this merging function. As it gives this array to this merging function, and as I've covered already in my video, what this merging function does is it will divide this array into two parts and then sort it and create another sorted array, which is this. Now this 2 and 4 is a sorted array, and it does nothing but just copy the values here. So it will copy the value 2 and 4. Now as when the function reaches here, it will return the sorted array, and the values being copied to this array, this function also get completed. As this function gets completed, the stack goes back here. The stack goes back to here. It goes back here, which is 0 and 3. As the stack goes back here, as the stack goes back here, as we are doing it recursively, I told you to think it recursively. That's why we are using these functions again and again, because they are being called again and again. So as it gets back here, so this function, as you can see that this is completed, this is completed, this is completed. So this is completed as it is directly linking to this. So as this gets completed, this function automatically gets completed because these two are sorted. So this is completed, and it goes down here, and it provides these 1 and 2 values again to here, and the values which are being provided is the array A, the value 2 and 3, the value 2 and 3, and this function get added into the stack. And as this function get added into the stack, it goes here. It sees that yes, 2 is less than 3. So Q is being calculated again. Q is 2 plus 3 divided by 2 is 2.5, which means 2. So which means 2 and 3. Forget these values. It's 2 and 3. It goes down. It calls it again. The values which are being further provided is 8, 2 and 2. As I told you earlier, whenever we have two equal values, this function will return nothing. This function will return nothing. This function gets completed. The control flow goes back to this function. This function has 3 and 3 value, as the value of q is 2. Q plus 2 plus 1 is 3, and the value of r is 3 here. The array which is provided is this. So as I told you, whenever we have a single value in an array, the function will return nothing. So this function is also removed from the stack. It goes back down here. The array which is provided is this. It will partition this array into two parts and then sort the values and create another array and then copy the values here, 1 and 6. Now as this function gets completed, this function also gets completed, as this is directly linking to this function. This function also gets completed. When this function gets completed, the control flow goes back to all this function. As this function is completed, as this is sorted, and as this is sorted, it goes back down here. Now this merging function will further divide this array into two equal parts and then merge it into a single sorted array, and this array which is further formed is this, and it will copy those values into this array. 1 2 This is 2. I'm sorry for my handwriting, it is very bad. 1 2 4 and 6. This is 1 2 4 and 6. As you saw here, this is 1 2 4 and 6. And when this 0 to 3 function gets completed and it returns a 0 to 3 sorted array, this function gets completed, and this function also gets completed. As this function gets completed, the control flow recursively goes back to this, and the array which is provided is this, and this array is being further provided here. Now it will divide the array into the first part, as the values which have been provided is 4 5 6 and 7. It will give 4 to 7, it goes down here. 4 is less than 7, it goes down here, and it get when it gets here, it adds this into the stack, it goes down here. 4 is less than 7, it goes back down here. Q is being calculated, which is 4 plus 7 divided by 2 is 5.5, and it is 5, so it goes down here. The values which are being passed in this function is array 4 and 5, this which means this. It goes down here. 4 is less than 5, q is being calculated again, which means 4. It goes down here. This function is being called again. The values which are provided are a, 4 and 4. So as I told you earlier, whenever we have only a single element in the array, this function will return nothing. This function will return nothing. And as it does nothing, the control flow goes back here. Q is 4 plus 1 is 5, R is 5. This has a single element in the array. It will return nothing because 5 is not equals to 5. 5 is not less than 5, it is equals to 5. So it will return nothing as we have nothing below here. So this function will return nothing as this function gets removed from the stack. So what we have is this. Now the control flow goes back here. This function is being called, which will divide the array into two equal parts and then sort it into a sorted array, and then copies the value here. Oh, such a beautiful 5 I make. And it copies the value in this array 5 and 8. And this function gets completed. As this function gets completed, the control flow goes back to the function here, and this function also gets completed as it was here. This whole function gets completed. This function gets, as when this function gets completed, the control flow goes back here. The values which are being provided here is 2 and 3. The values which are being provided here is 2 and 3. As 2 is less than 3, it goes here. Q is being calculated, which is 2. In this case, it goes back here, and when it goes here, 2 is equals to 2. So 2 is equals to 2. When the values become equal, that means this function will return nothing. As this function will return nothing, this will complete it. This will get completed, and it goes down as and the values that are provided are q plus 1 and r, which means this value, this q as q at this point was 6, plus 1 is 7, and r is 7. So the array which is being provided is this. So this array has only a single value, and as I told you earlier, whenever we have a single element in the array, we will return nothing, and as this will return nothing, this function gets completed. Now and now the control flow goes back to this function. We have this array 7 and 1, sorry for this black mark, and now this function will divide this array into two equal parts and then sort it up and then put these values here in this function 1 and 7. Now as this function gets completed, which means that this function is being completed, the control flow goes back to this function recursively. Think recursively, I'm telling you again. Now the control flow is back to 4 and 5, 0 to 7. The control flow is from 0 to 7. This function is completed already as this is connected to this function. This function is completed already as it is connected to this function. See the connections. Connections are very, very important, I'm telling you. And now this function, now the control flow reaches from 0 to 7. Now the merging function has 0 to 7 values. It will further divide this array into two parts, and as you can see that 5 and 8 are sorted, 1 and 7 are sorted. So the merging function will divide those array into two parts and then sort it up in 1, 5, 7, 8, and then put those values here 1, 5, 7 and 8. Now as this function gets completed, the control and this will return 8 and 7 sorted. This function will create this. Now this function is completed, this function also get completed. The control flow reaches back here, as both of this function is recursively completed, and the control flow reaches here. Now the array which we have finally is this. The merging function will divide this array into two equal parts. This is being divided into two equal parts. Now 1, 2, 4, 6 is sorted. 1, 5, 7, 8 is sorted. But 1, 2, 4, 6, 1, 5, 7, 8 is not sorted. So the merging function will divide into two equal parts and that sort it to form the final sorted array, which is 1, 1, 2, 4, 5, 6, 7, 8. And then when this array is sorted from 0 to 7, this function is finally removed from the stack. Now the stack is empty, we have nothing in the stack, all the functions are completed, and we have our sorted array. So that's all. That is all in the merging sort. And if you cross this, pause the video, try to listen my explanation again and again, think recursively. This is the only way to understand this algorithm, as when I understand it with this binary, this tree, but I've put in a lot of effort to make this stack. So it will make this algorithm a lot easier for you guys, but you have to run your brains quite hard to get this algorithm. So that's all for this video. If you want to support the channel, well, there are a couple of ways you can do that. You can subscribe to the channel, as I post regularly on programming videos in Java and data structures. And if you think that this video is helpful for someone, you can share the video. And thank you so very much. And I'm telling you again to look to the algorithm again and again, and listen to my explanation again and again, and think recursively. Thank you so very much.